Hey everybody, welcome back. This is lesson 2 in our unit 7, and today we're going to be talking about solubility guidelines, which can be found on table F of your chemistry reference table. So in the last video, we talked about properties of water and kind of introduced all the very many words that look and sound the same of solutions. And so today we're going to take a closer look to see, if something is soluble or not. So again, that's solubility guidelines, table F on your chemistry reference table. So, quick recap. If something is soluble, that means it can be dissolved, especially in water. So soluble is dissolvable. If something is insoluble, it cannot dissolve. So those two words are something that you really need to know for this video because we're going to be talking about soluble versus insoluble compounds all video. So soluble can be dissolved, insoluble cannot. So table F, first of all, the solubility of ionic compounds, so ionic compounds, metal, non-metal, most of them are very, very soluble, some of them not so much. And so we're able to kind of tell by looking at table F. And so generally these strong electrolytes are also very, very soluble in water. And oppositely speaking, the weak electrolytes are kind of slightly soluble in water. And so just knowing that some things can and some things can't dissolve, that is important. Okay, so one thing to point out is that when you have an insoluble substance, so let's say you have compound A and compound B put together, and you say, a precipitate forms. So let's say you have, this is A, and you're mixing, let's say, B, and you're trying to make C, so you put those two together, but you get this stuff on the bottom. So in they're separate things, they're, soluble, but then you get this, stuff on the bottom. That's a precipitate, that's that precipitate. That is an insoluble solid. So if it asks about precipitates, you're looking for something that is insoluble. And so if something is solid, if you were to pour this through a funnel, the green stuff would stay behind and the water would pass right through. So there would be that green stuff. But let's say if you were to pour something that is soluble, so let's say this is salt in water, so let's say NaCl. If you pour something that's soluble through a funnel, everything pours right through, nothing gets stuck. So funnels or filtration only really take out these solid things, and it's solid if it is insoluble. Okay, so here's table F. Now, the way this works, there are two sides to it. So ions that form soluble compounds. So compounds with group 1 ions, always soluble. Compound with NH4 plus, soluble. Compound with NO3. With any of these things are always, always, always soluble. So it doesn't matter what it's attached to. If you see Na or anything in group 1 in a compound, you know it has to be soluble because there are no exceptions. Now we get to this point where halides, so that's your group 17, you have chlorine, bromine, iodine, those are always soluble except when connected with one of those three things. So let's say NaCl, you have that Cl, and Na is not one of those exceptions, so NaCl is good. But if you have AgCl, you see Cl, you're like, oh, maybe I'm good because chlorine is a halide. But when it's chlorine, bromine, or iodine is matched with silver, lead, or mercury, you have that silver, that is not soluble. So same thing with sulfates. Anything with SO4 is soluble except when it's AgCaSO or any of these group 2 things or lead. So keeping those exceptions is important. A lot of the Regents questions love asking about exceptions. So again, this is getting kind of messy. All of these things can form soluble compounds. They can dissolve, except for this handful of exceptions. Now, the other half of the table, these are insoluble compounds. So if you see something with CO3, CrO4, PO4, S, or OH, those are insoluble, except, and we have those exceptions when it's connected with these things. So let's say we have CO3. You have CO3. CO3 is insoluble, and Ba is group 2, I believe. Let me just double check that. Yes, so Ba is group 2. So what this exception says is that anything attached to carbonate is insoluble except group 1 or NH4. But since Ba is in group 2, this is an insoluble compound. And that's kind of how that would work. It just takes kind of some practice looking at this table. So again, for example, anything with the hydroxide or the OH polyatomic ion is insoluble unless it's group 1, anything in group 1. So Li, Na, K, Rb, Cs, and Fr, or calcium, Ba, Sr, and NH4+. So again, just looking at this, kind of practicing with the exceptions, that is important. So let's do a few questions together so you can kind of see what I mean. Question number 1 says, according to reference table F, which substance is the most soluble? So when it says most soluble, generally 3 out of the 4 will be insoluble, and then you have that one soluble one. So finding the one that's different. So you're going to want to look at each one of these answer choices. And so our first one is AgI. So I is a halide. So you might be thinking, oh, hey, it's soluble. It's in the soluble column. But when I is combined with Ag, Pb, or Hg, it is not soluble. So that I in Hg makes this insoluble. That's one of the exceptions. Let's look at choice B, calcium sulfate. So sulfate, you're like, okay, cool, anything with SO4 is soluble, except if it's combined with Ca, Sr, Ba, Pb, or Ag. And so calcium is one of these exceptions, and so that is also insoluble. Keeping on moving, PbCl2. Okay, cool, Cl is soluble, but Pb is that exception that is insoluble. So process of elimination, you can definitely go with D, but let's just work this one out. So NH4CO3, NH4 is always soluble, and there are never ever any exceptions. So that is your soluble. That's the one that's different. Therefore, D is going to be your answer. Okay. Question number 2, based on reference table F, which one of these saturated solutions has the lowest concentration of dissolved ions? So in order to have the lowest concentration of dissolved ions, you want something that's not dissolved, or that doesn't dissolve well. So if something dissolves really well, you have a whole bunch of those ions. But if something does not dissolve well, then you don't have these ions. So if it does not dissolve, we know that is going to be insoluble. So we're looking for which one of these compounds is insoluble. So going through the list again, it's good to go one by one. NaCl, let's look at Na or Cl, but Na comes first. Anything with Na is soluble, no exceptions. This one is good. If you look at MgCl2, so let's find Cl on there. And so anything with Cl is soluble except Ag, Pb, or Hg. Magnesium is neither one of those exceptions. That is soluble. In the same place, nickel chloride. Again, anything with Cl is soluble except silver, lead, or mercury. Nickel is neither one of those. That is soluble. And then AgCl. Again, anything with Cl is soluble except Ag, Pb, Hg. Oh hey, Ag makes it insoluble, and therefore D is your answer. Moving forward, we're going to do 2 more questions together. When PbI2 is added to Na2CO3, a white precipitate is formed. According to the reference table, the white precipitate most likely is. So again, if we're talking about a precipitate, we're talking about something that is insoluble. Now you totally could write out the chemical equation and get your thing, PbCO3 plus NaI. But if you don't know how to break apart reactions yet, that's okay. It doesn't really help. So basically we're looking, because now these are where these answer choices come from. But we're looking for something that is insoluble. So our question really is, forgetting everything else, which one of these is insoluble? So if we look at A first, anything with K, so K is group 1, is soluble. Also NO3, there is no exceptions. That is always going to be soluble. That cannot form a precipitate. Lead carbonate, anything with CO3, that's over here, is insoluble, except group 1 or NH4. Pb is neither of those things. That is your insoluble. Now you could also go back and check the other 2. Let's just do that. Na is in group 1, no exceptions, soluble. Again, Na, no exceptions, is soluble. If you look at it from the other end, CO3 is insoluble except when it's combined with group 1 or NH4. Na is group 1, so it's soluble. So again, you're looking for something that doesn't match the other ones. And lastly, number 4, which precipitate does the following reaction form? So we're given this thing, and we are trying to figure out, again, precipitate means something is insoluble. And so, let me just write that over there. I'll need this space. Now we're given the formulas of the thing. So let's just look at, and the name. So let's look at the formulas first. That might help us. And so, anything in NO3 is soluble. So that can't make a precipitate. Anything with Na, no exceptions, that is soluble. Again, this one, anything with Na, no exceptions, is soluble. But then you have at BaSO4. SO4 now is soluble, but with the exception Ba, this makes that insoluble. So now we're looking for the name of this. And so Ba is barium. So we're looking for something that says barium, and then SO4, according to that, is your sulfate. So barium sulfate is going to be your answer. And that's it. Again, it's just practice with this table. Now, that is it for this video. In the next video, we will talk about factors that affect solubility. So factors that change the amount of stuff you're able to dissolve in a solution. So that is it.